Right, today in Algebra 2, we're going to look at Section 1.2, Transformations of Functions. Our essential question, what do the differences between the equation of a function and the equation of its parent function tell you about the differences in the graphs of the two functions? After today and tomorrow, you should be able to apply transformations to graph functions and write equations. So we're going to start out, number one, we want to graph f of x equals the absolute value of x. And I've already started an xy table for us. So these are all the x values we're going to plug in. So if I plug in -2, the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Okay, so now we want to plot those points. So we're at 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. We remember that absolute value is a V shape. Now we're going to switch colors. We're going to graph f of x equals absolute value of x plus 2. So if I plug -2 in, -2 plus 2 is 0. The absolute value of 0 is 0. Plug in -1. -1 plus 2 is 1. The absolute value of 1 is 1. Plug in 0. 0 plus 2 is 2. Absolute value of 2 is 2. Plug in 1, and we get 3. 2, we get 4. Plot these points, and we're at -2, 0, -1, 1, 0, 2, 1, 3, 2, 4. I know I need a V shape. I see I have the right-hand side going on, but I don't have anything else going to the left of -2, so we're going to add to our graph, or our XY table, we're going to add -3 and -4 to our X values. So if I plug in -3, -3 plus 2 is -1, absolute value of -1 is 1. -4 plus 2 is -2, but the absolute value is 2. So then we have over -3 up 1, over -4 up 2. Draw the V. What do we notice happened to the original graph, the one in purple? So my red graph, it took the original graph that started at 0, 0 with the vertex, and it moved that vertex to the left 2 units. So this went left 2 units. We're going to switch colors again, and now we're going to do absolute value of x and then plus 2. So absolute value of -2 is 2. 2 plus 2 is 4. Absolute value of -1 is 1. 1 plus 2 is 3. Absolute value of 0 is 0. 0 plus 2 is 2. Absolute value of 1 is 1. 1 plus 2 is 3. Absolute value of 2 is 2. 2 plus 2 is 4. We're going to plot those points. So over -2 up 4. Over -1 up 3. 0 was at 2. 1 was at 3. 2 was at 4. Draw the V shape. And again, how did that relate to the original one that we graphed in the purple? We see that the vertex started at 0, 0, and now it is at 0, 2. So it took that purple graph and it shifted it up 2 units. So this one went up 2 units. I'm going to switch colors again. And now we're going to do f of x equals 1/2 x, absolute value of all of that. When we have a number inside, okay, absolute value or inside parentheses, this is a horizontal. We're dealing with the horizontal, okay? We'll see what I'm talking about here in just a minute. So if I plug in -2, 1/2 of -2 is -1, the absolute value is 1. 1/2 times -1 is -1/2, but its absolute value is 1/2. 0 is just 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. So now we're going to plot those points. So over -2 up 1. Over -1 up 1/2. 0 is still 0. Over 1 is still 1/2. 2 up 1. Draw that graph. And we're looking at what happened to the blue graph compared to the original purple graph. we see that our vertex stayed the same, but it got wider, okay? So it stretched it out. Because the number was on the inside, this is called a horizontal stretch. So basically this got wider. We're going to add another one that I don't have on here. So let's switch colors again, and let's graph f of x equals 2 times the absolute value of x. So this time when it's on the outside, this is going to affect the graph vertically. And we're going to make an xy table. -2, -1, 0, 1, and 2. Absolute value of -2 is 2. 2 times 2 is 4. Absolute value of -1 is 1. 1 times 2 is 2. It's going to be 0, 2, and 4. So plot these points over -2 up 4. Over -1 up 2, 0, 0 still, over 1 up 1, over 2 up 4, and draw that graph and compare what's my yellow graph compared to my purple graph. We see that it got skinnier or narrower, so this is called a vertical stretch. Because it got narrow. Okay. So the number on the outside affects it vertically. The number on the inside affects it horizontally. So now, based off of kind of the patterns that we're seeing, without graphing, what do you think the following would do to the graph? Absolute value of x minus 2. So we noticed that when it was the absolute value of x plus 2, it went left 2. So if it's an x minus 2, it would go right 2. Number 2, the absolute value of x minus 2 on the outside. We notice over here where we had the absolute value of x plus 2 on the outside went up 2. So the minus 2 on the outside is going to shift the graph down 2. So now let's look at f of x equals -6 times the absolute value of x plus 6, all of that plus 8. We see inside, it's an x plus 6. When it was a plus on the inside, it went left. So I know it's going to go left 6. It has a plus 8 on the outside. Pluses on the outside moved it up, so it's going to go up 8. Remember that negative tells me that it's going to open down. It reflects it. And the 6 is on the outside, so we know that this is a vertical stretch, which means it's going to get narrow. Okay. All right, so now let's flip the paper over. Let's take care of some vocabulary. So a translation is a kind of transformation of a function that shifts each point on a graph the same distance and direction. A reflection is a transformation that maps each point to a new point across the given line. That given line is called the line of reflection. A transformation that increases the distance between the points of a graph and a given line by the same factor is called a stretch. A transformation that decreases the distance between the points of a graph and the given line by the same factor is called a compression. And then a parent function is the function without any transformations. So we're going to look at our parent function f of x equals x squared. This is a quadratic. When we graph it, that's our parabola, which is a U shape. Transformations that we can have. F of x equals a parentheses x minus h quantity squared plus k. The h inside parentheses moves it left or right. Anything inside parentheses is always opposite when it comes out. So x minus h moves to the right. Because when we come out, To solve x minus h, I would have to add h to both sides. So it's moving to the right. X plus h moves left. The k on the outside moves it up or down. If it's a positive k, it moves up. Negative k moves down. A negative a is simply a reflection. Now we're going to talk about vertical stretches and compressions and horizontal stretches and compressions. So here we're just going to talk about stretches and compressions. We can get rid of that vertical right there. We're going to talk about both of them. So this first picture shows me vertical. Okay? The black graph is the parent. Okay, so the black graph is the parent. It tells me, right, that it's a stretch when k is greater than 1. Okay, so like 1.5, 2, 3, 4. It's a vertical stretch. Okay, so vertical stretch, I'm just going to say VS. That's like imagining that we are pulling the graph up and down from the top and the bottom. Okay, we're stretching that graph out, and so we see that if I took this black, okay, and I pulled that part up, I'm going there. The original parent, if I pulled it down, it's coming down here. I'm stretching it vertically. Vertically is up and down. So then we have a vertical compression when k, that number that we're multiplying it by, is between 0 and 1. So it's a fraction, like 1/2, 1/3, 1/4. Okay? And I'm just going to switch colors here. So a vertical compression is like we're pushing it down from the top and pushing it up from the bottom. So if I take this, the black, and I push it down, I'm ending up right there at that blue. If I take the black and I push it up, so this is pushing down from the top and push up from the bottom. That's a vertical compression. So now horizontal. Horizontal is when the number, okay, is inside the parentheses or the absolute value. So we're multiplying the x by it. Okay? So again, the black is the parent function. So it tells us a stretch is when k is between 0 and 1. So a fraction, 1/3, 1/2, 1/4, 1/5. So a horizontal stretch is when I'm pulling out left and right. So I pull out from the left and right. So if I took that parent function, the black, and I stretched it horizontally, because remember horizontal, it's like the x-axis. I stretch it out, I'm moving right there. Bring this, and I stretch it out, I'm right here. So then a horizontal compression, when k is greater than 1, so like 1.5, 2, 3, 4, this is when I push in from the left and right. So if I start at the black and I push it in, I'm here at the blue. Start at the black and I push it in, I'm there at that blue. Okay. So that's how we tell the difference whether it is a compression or a stretch. If it's vertical, the K, the number's on the outside. If it's horizontal, the number's on the inside. We will always start with our parent function. Okay? Then we follow HSRV to graph any transformations. The order is extremely important. You always go HSRV. H stands for any horizontal movement, left or right. Okay, so this is left or right. The S stands for any stretches or compressions. These are both vertical and horizontal. The R stands for any reflections. And the V stands for any vertical shifts, which means up or down. And so that's the order that we would graph them in. We do horizontal left to right first, stretching or compressing, reflecting, and then shifting up or down. Steps to graph. We want to identify the parent function. Make an XY table for the parent function. It must include at least 5 points. Identify HSRV in that order. Create a new XY table for the transformations and then graph. So let's just review some parent functions that we've talked about, okay? F of x equals x. Remember, this is a line. F of x equals the absolute value of x. Remember, this is an absolute value. It's a V shape. F of x equals x squared is a quadratic, which is called a parabola when we graph it, and it's a U shape. All right, so now let's practice graphing these based off of transformations. So we're going to graph f of x equals x squared minus 3. So first we want to identify the parents. Okay, the three parents we just talked about were x, absolute value of x, and x squared. So this one's parent is obviously x squared. So H, left to right. I have to have parentheses in order to have a left or right horizontal shifting. I have no parentheses with my x squared, so I have none. And you have to indicate to me that you know that there are none. So you can write the word none, or you can draw a line through it. If you leave it blank, I think you just didn't know and you didn't answer it, and it gets marked wrong. S, that is a vertical or horizontal stretch or compression. I have to have a number in front of x. I do not have one of those, so I have nothing here. R is a reflection. I only have a reflection if I have a negative A. Let me make sure that we didn't skip that over here. Nope, we didn't. We have that right here. Negative A is our reflection. So I have none. V, that's a vertical shift, up or down. That was, do I have something added or subtracted to the entire thing? Here I have a minus 3, so that means this goes down 3. So I've identified my HSRV. Now I make a XY table of my parent function. X squared, the parent function, I will always use the points, -2, -1, 0, 1, and 2. I have 5 points. If I plugged each of these points into x squared, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. This is the parent function and the XY table I will always use for parabolas, every single one. So now I'm going to make a new XY table with my HSRVs. H affects my X, right? Everything else affects Y. I did not have any X change, so all of my X's stay the same. So I'm going to have the exact same X's as I did in my parent. -2, -1, 0, 1, and 2. The only thing that I had that affected Y was down 3. So I'm going to take my Y and I'm going to subtract 3 from it. So all of these Y's in my parent, I'm going to subtract 3. So I start with the top one. 4 minus 3 gives me 1. 1 minus 3 gives me -2. 0 minus 3, -3. 1 minus 3, -2. 4 minus 3, 1. This now is what I'm going to graph this XY table, because that's going to give me this function, f of x equals x squared minus 3. Because basically it took my parent function and it shifted every single point down 3. So my new vertex is this 0, -3. That's my turning point. 1, -2, 2, 1. -1, -2, -2, 1. And I know it's a U shape, so I'm drawing my U with my arrows. There's our first graph. So now let's look at number 2. F of x equals the absolute value of x minus 4. Its parent was the absolute value of x. Horizontal, that means it's something inside, okay? If it's a parabola, it's inside parentheses. If it's an absolute value, it's inside absolute value. I have an x minus 4 inside. Remember that it always comes outside opposite. So I would have to add 4 to bring it out. So that means it's going right 4 spaces. Stretch or compression, that means I have to have a number multiplied by the x. I don't have one. Reflection means I need a negative out front. I don't have one. Vertical means I need a number being added or subtracted on the outside. I don't have one. So the only thing that's happening to this parent function is it's going to the right 4. It's taking every single point from the parent and shifting it to the right 4. So we want the parent function absolute value of x. Again, we make an xy table for that. We use the same x values, so that's nice. We don't have a lot to remember. -2, -1, 0, 1, and 2. Plug them in. The absolute value of -2 is 2. Absolute value of -1 is 1, 0, 1, and 2. Now I make my new xy table. Remember, h of x, everything else is y. I had a right 4, so what I put in my xy table is the opposite of what was inside here. So x plus 4. My y's are all going to stay the same. So all of these y values stay the same. So now I'm going to have a 2, a 1, a 0, a 1, and a 2. I take each of these x values and I add 4. -2 plus 4 puts me at 2. -1 plus 4 is 3. 0 plus 4, 4. 1 plus 4, 5. 2 plus 4, 6. And then this is what we graph. And that will give us f of x equals absolute value of x minus 4. So it took my vertex at 0, 0, and it shifted it over to 4, 0. 5, 1, 6, 2. 3, 1, 2, 2. Absolute value, so it's a V shape. Let's look at number 3. The parent, f of x equals -2, parentheses, x plus 1, quantity squared, all of that plus 1. So we have lots of things here. Again, I have a squared, so its parent is x squared. H, I have parentheses, it's x plus 1. It comes out opposite. It's going left 1. That's my x. All of these are my y's. S, I have a number out front. It's 2. Okay? The number out front, remember, is a vertical. The number bigger than 1 is a stretch. So it's a vertical stretch, okay, by 2. Or, yes, I have a reflection because I have a negative out there. V, I have a plus 1 at the end, so yes, it's shifting it up 1. So again, xy table of our parent, -2, -1, 0, 1, and 2, -2 squared, 4, 1, 0, 1, 4. My new xy table. The left one is the only thing that affects the x. It was x plus 1 in parentheses. It always comes out opposite. So in my table, it's x minus 1. All of these affect y, and I go in this order. Okay? So S and R, okay? It was a -2, so I have to multiply -2 times y, and then my v was up 1, so then I add 1. So I'm going to change all of the x's and all of the y's in my parent function. So to all of these x's, we're going to subtract 1. So -2 minus 1 puts me at -3. -1 minus 1, -2. 0 minus 1, -1. 1 minus 1, 0. 2 minus 1, 1. Now I have to go this order. I have to multiply these y's by -2, then add 1. Okay, so order is very important. So I have to do the S, then the R, then the V. So 4 times -2 is -8. -8 plus 1, -7. 1 times -2 is -2. -2 plus 1, -1. 0 times -2 is 0. 0 plus 1 is 1. 1 times -2 is -2. -2 plus 1, 1. Sorry, -1. 4 times -2 is -8. -8 plus 1, -7. And notice that they are always my vertex, right? My original function, my vertex, and the points above it, they're always the same y values, okay? So this is my vertex, right? -1, 7, -1, 7, because it's a mirror if I was to fold it over. So plot these points. -3 down, -7. It's going to be just right off my graph. -2, -1, -1, up 1, 0, -1, and 1, -7. So there is my graph. It's a reflection because now it's opening down. So that means that this, my vertex, is a maximum, right? It shifted the vertex from 0, 0. It shifted it over 1 and up 1. And it vertically stretched it by a factor of 2. So if I was pulling the top and the bottom, so it stretched it or made it get narrower. Okay, let's look at another one. F of x equals -1/2 x plus 2. Okay, what's its parent? Its parent is just x, the line. Right? So HSRV, I don't have any parentheses, so nothing left or right. S, yes, I have a number out in front, so this is a vertical stretch by 1/2. Reflection, yes, because I have a negative. And then plus 2, yes, so it's going up 2 for vertical. So my parent is x. My xy table, you can still use the same points, -2, -1, 0, 1, and 2. My y's will all be the same, right? Because this is f of x equals x. So -1, 0, 1, and 2. So my new one, my x's all stay the same, -2, -1, 0, 1, and 2. My y's, I have to multiply y by 1/2 and negative. So -1/2 y, and then I add 2 to all of them. So -2 times a -1/2, that puts me at +1. +1 plus 2 puts me at 3. -1 times -1/2 puts me at +1/2. 1/2 plus 2 puts me at 2.5. 0 times -1/2 is 0, plus 2 is 2. -1/2 times 1 is -1/2 plus 2, so I'm at 1.5. 2 times -1/2 puts me at -1. -1 plus 2 is 1. These are the points I'm going to plot. So -2 up 3. -1 up 2.5. 0 up 2. Over 1 up 1.5. Over 2 up 1. Straight line. So the vertical stretch by 1/2, okay, notice our slope changed. The apparent function, my slope is 1, okay? So I would have been up 1 over 1 or down 1 over 1. So notice I don't go down 1 over a whole point, right? I didn't go down 1 whole point. I went down 1/2, okay? Or down 1 over 2 is what we went from this point, right? We went down 1 over. So it's not as steep. This line is not as steep as its parent. All right, let's go to the back. So now we're going to look at, they give me a graph. It represents some function y equals f of x. Okay, let's go ahead and write down what our x's and our y's are, the table. So let's see, this point is -4, 2. This point is -3. So at -3, my y value is 3. At -2, my y value is 4. At -1, back at 3. At 0, I'm up at 5. 1, let's see, we're up at 7. So those are the points of our parent, okay? So now it says graph y equals -f of x plus 2. So what do we have? This negative tells me I have the negative tells me I have a reflection. And inside parentheses tells me I go left 2. So this is an x, this is a y. So if I make a new xy table, I'm going to have x minus 2 because it always comes out opposite. and then I'm going to have a negative y. So I'm going to subtract 2 from all of these x's. Negative 4 minus 2 puts me at negative 6. I don't know why it wants to do that. Let's erase that again. So negative 4 minus 2, negative 6. Negative 3 minus 2, negative 5. Negative 2 minus 2, negative 4. Negative 1 minus 2, negative 3. 0 minus 2, negative 2. 1 minus 2, negative 1. And I'm going to just change the sign of all of my y's. So this is going to be negative 2, negative 3, negative 4, negative 3, negative 5, negative 7. We're going to plot those points. So over negative 6, down negative 2. Negative 5, negative 3. Negative 4, negative 4. Negative 3, negative 3. Negative 2, negative 5, negative 1, negative 7. And then I'm going to draw that graph. So I can see that this graph is that blue graph reflected and then shifted left 2. So I reflected it over the x-axis. So if I reflect that over the x-axis, I'm down here. And then I shift over 2, 1, 2. That point matches up. Okay? So now I'm just going to switch colors. Let's look at the next one. Y equals 1/2 f of x plus 3. My 1/2 is on the outside. It's a fraction smaller than 1, so I know that this is a vertical compression by 1/2. Then the plus 3 tells me that it goes up 3. So my new XY table, I didn't have anything that affected my x's. My y's, it's 1/2 y plus 3. So all of my original x's stay. So negative 4, negative 3, negative 2, negative 1, 0, and 1. So now I'm going to take my original y's, I'm going to multiply them by 1/2 and then add 3. 2 times 1/2 is 1, 1 plus 3 is 4. 3 times 1/2 is 1.5. 1.5 plus 3 is 4.5. Let's see. 4 times 1/2 is 2. 2 plus 3 is 5. 3 times 1/2 is 1.5. 1.5 plus 3 is 4.5. 5 times 1.5. 5 times 1/2 is 2.5. 2.5 plus 3 is 5.5. 7 times 1/2 is 7 halves, or 4.5 plus 3. 3.5 plus 3, 6.5. These are the points we're going to graph now. So over negative 4, up 4. Over negative 3, up 4.5. Over negative 2, up 5. Over negative 1, up 4.5. Over 0, up 5.5. And over 1, up 6.5. Connect. And those are my points. So I see that it shifted up by 3. Right? So it took that and it went up by 3. And then it compressed it or flattened it out by 1/2. Right, that's where we're going to stop for day number 1. Tomorrow we will look at identifying the transformations from a graph and writing the equations.